Okay, sample problem 4.2. Classify each of the following compounds as soluble or insoluble in water. A, AgNO3, which is called silver nitrate. B, CaSO4, calcium sulfate. C, K2CO3, potassium carbonate. Okay, so here we're going to use what are called the solubility guidelines. We're going to go over those in just a minute. This topic is specifically dealing with ionic compounds. If you watched the solution to sample problem 4.1, I talked a little bit about ionic compounds. And what I said was that the view of ionic compounds in that section was simplistic and not real. And here's where we're going to get into the details of that. It turns out some ionic compounds dissolve in water and form electrolytes, so they would be called strong electrolytes. Others dissolve a little bit, so they are weak electrolytes, and some do not dissolve at all, so they're called non-electrolytes. Now, I don't want to unconvince you from the previous problem 4.1. When you're doing that sort of problem, strong, weak, non-electrolytes, you want to use the approach that ionic compounds are strong electrolytes. But here we're going to see for this type of problem that some compounds don't dissolve, some ionic compounds don't dissolve in water, so they would be non-electrolytes, in fact. So let's take a look at how we go about this. The first one is A. I'm going to go over that one first, which is silver nitrate. Now, how do we know it's an ionic compound? How did we decide that before? What we said was that if it had a metal and a nonmetal, that would be an ionic compound. Well, silver's a metal, right? So again, make sure you're familiar in the periodic table where the metals are, okay? Silver is a metal. Well, we know that silver's a metal, right? We've all worked with silver to some extent. Okay, so this is an ionic compound. Now, to determine whether it's soluble, and remember, the term soluble, all that means is dissolves in. So we know that sugar dissolves in water, right? So it's soluble. But we also know that if you throw a rock into water, the rock just falls to the bottom and it doesn't dissolve. So we call that insoluble. Does not dissolve. Okay? And generally we're talking about water. We're not going to worry about other types of organic solvents or anything like that for this course. So if something dissolves in water, it's soluble. If it does not dissolve in water, it is insoluble. Okay? So how do we tell? How do we know if silver nitrate is soluble or not? Very simple answer to that question. I'm going to come back up here to what are called the solubility guidelines, which are in table 4.2 and 4.3. The solubility guidelines tell you whether something is soluble. And so all you do is you go through this list and figure it out. Okay? Now there are other types of lists, other types of charts that are used out there, but I'm going to focus on this one that's in your textbook, your eBook, if you have that. So here are the soluble guidelines. Water-soluble compounds. With a few exceptions, there are some exceptions to these, and they're listed here. A compound that has an alkali metal, lithium, sodium, potassium, rubidium, or cesium, or ammonium, are always soluble in water. Compounds that have the nitrate ion, the acetate ion, or the chlorate ion are soluble in water. Compounds containing the chloride ion, bromide ion, and iodide ion, they are generally soluble with a few exceptions, and that is if they're combined with silver, mercury 1, or lead 2. Compounds that have the sulfate ion are generally soluble in water unless they are combined with silver, mercury 1, lead 2, calcium, strontium, or barium. So what you do is you just look through and see if it's in one of those lists. And if you look at it, see how it's NO3? NO3 is nitrate. This is silver nitrate. The key here is that nitrate. That's soluble because if we come back up to the second rule at the top, compounds containing the nitrate ion, NO3-, they are soluble and there are no exceptions. So that right there, from that discussion, we know that this one is soluble. Now let's work on to B. B is calcium sulfate, CaSO4. Okay, so we're going to look for a rule about calcium, and we're going to look for a rule about sulfate. It's a good idea in terms of these ionic compounds. Think of them as having two parts. The metal part, which is positive, and the non-metal part, which is negative. These are ionic compounds, positive, negative. Okay? So silver nitrate, the silver was positive and the nitrate was negative. For calcium sulfate, the calcium is positive and the sulfate is negative. Again, calcium is a metal. Sulfate's a non-metal. Right? Metal, non-metal. So this is an ionic compound. So we look for calcium and we look for sulfate. And we see, okay, let's go through the first list. Lithium, sodium, potassium, rubidium, cesium, ammonium. Nope. Nitrate, acetate, chlorate. Nope. Chloride, bromide, iodide. Nope. Silver, mercury, lead. Nope. Sulfate. Oh, here it is. Sulfate. SO4 2 minus. Sulfate. Okay, they're soluble. Unless they're with silver, mercury, lead, calcium, strontium, or barium. Okay, calcium, there's our exception. So in other words, sulfates are soluble unless they're with one of those. Well, calcium is one of those, right? Calcium is one of those exceptions. So insoluble. Okay, so you have to know how to interpret that. That's the exception. If it's with a calcium or a barium or a lead or a silver, it's insoluble. Okay, so now we go on to part C. Part C is K2CO3. Can you name that? Do you know how to name that? Potassium carbonate. Positive, negative. These are ionic compounds. Metal, non-metal, right? Potassium carbonate. Ever wondered why potassium starts with a K and not a P? P is phosphorus, right? It actually comes from the Latin, kalium. Kalium, K. Potassium is kalium. Okay, so how do we deal with this? We look at the positive and we look at the negative, and we look for them in those two charts there. I haven't talked about the second chart, but it's there too. So we look for potassium, way up at the top, lithium, sodium, oh, there it is, potassium. No exceptions, always soluble. Well, there you go. No exceptions, always soluble. All right, so it's soluble. There you go. So there's our three. Using these two charts. Now, we didn't look at any that actually had anything from table 4.2, but these ones are insoluble. So if it has carbonate, phosphate, chromate, or sulfide, insoluble, except with lithium, sodium, potassium, rubidium, cesium, or ammonium. Those ions shown on the right for the exceptions, those are the same ions that were shown in table 4.2. Those are always soluble. So carbonate, phosphate, chromate, sulfide are not soluble. They're insoluble unless they're with the list on the right. Same thing for hydroxide. They're insoluble. They do not dissolve in water, do not form electrolytes unless they're with the same ions that are shown there on the right. Okay, and there you go. There's sample problem 4.2.